Imagine a single planet worth more than every dollar, every euro, every rupee, every bar of gold on Earth combined. Not as a metaphor, as a price tag, because somewhere out in our galaxy are worlds that may be made almost entirely of diamond. Start with the closest. 41 light-years away, there's a planet astronomers nicknamed the Diamond Planet. Its name is 55 Cancri e. It's a super-Earth, about twice our size, 8 times our mass, and it's so dense that scientists once believed its insides were packed with carbon, squeezed by unimaginable pressure into a core of solid diamond. A planet you couldn't buy, a planet you couldn't even mine. But get closer, and the fairy tale curdles. 55 Cancri e orbits its star so tightly that a year there lasts just 18 hours. Its surface roasts at thousands of degrees. One whole side is very likely an ocean of molten lava. And here's the twist scientists only just uncovered. Using the James Webb Space Telescope, they watched this world lose its atmosphere to its star's fury, and then grow a brand new one, bubbling up out of that lava sea. A diamond heart, maybe, but a face of fire. Now, was it ever really diamond? Honestly, we're not sure. Newer measurements muddied the picture, and 55 Cancri e may be less carbon-rich than the headlines promised. So if you want a planet that is, beyond doubt, a diamond, we have to go somewhere far darker. 4,000 light-years away orbits a world with a past unlike anything else we've found. It circles a pulsar, the spinning corpse of a dead star, once every 2 hours. And this planet used to be a star itself. Long ago, it was a white dwarf, the burnt-out ember of a sun. Its companion, the pulsar, stripped it down layer by layer, crushing what remained under colossal gravity until its carbon crystallized. The result is a planet denser than diamond, a world that is, in all likelihood, a single vast crystal of carbon. A planet that is a diamond, born from the death of a star. And the universe doesn't stop there. Closer to home, about 50 light-years away, sits a white dwarf called BPM 37093, nicknamed Lucy, after the Beatles' Lucy in the Sky with Diamonds. As it cooled, its carbon interior began to crystallize, turning the dead star into something astonishing. A diamond the size of a star. 10 billion trillion carats of it. And here's the twist that should stop you cold. To find a world that makes diamonds, you don't have to cross thousands of light-years at all. You don't even have to leave our own solar system. 2 of them are our neighbors. Neptune and Uranus, the ice giants at the cold blue edge of the Sun's family. They are so far away and so little visited that only a single spacecraft has ever seen them up close. Voyager 2, which slipped past Uranus in 1986 and Neptune in 1989, and then vanished into the dark. No mission has been back since. From a distance, they look serene, pale, smooth, almost gentle. But their calm faces hide one of the strangest processes in the entire solar system. Sink beneath those clouds and travel down, thousands of miles down, and the world transforms. The pressure climbs to more than 1 million times what you feel standing on a beach. The temperature soars into the thousands of degrees, and in that crushing dark, the methane that gives these planets their blue color is torn apart, and its carbon is set loose. Then, under that impossible squeeze, the carbon does something extraordinary. It locks together into crystal, into diamond. Not diamond dust, solid gems, forming in the blackness and then sinking, slowly, for thousands of miles through the planet's interior. A glittering rain of diamonds falling toward the core. For a long time, this was only a beautiful theory. Then, in a laboratory in California, physicists set out to prove it. They took a thin sheet of ordinary plastic, carbon and hydrogen, the very same ingredients found inside the planets, and hit it with a pulse of intense laser light, recreating for a fraction of a second the pressure of an ice giant's depths. Then they watched with an X-ray beam, and in that instant, almost every carbon atom snapped into place as diamond. Tiny, real diamonds, born in the lab exactly as the theory promised. The rain is real, and the deeper scientists look, the stranger it gets. Some now believe the diamonds fall so thick and the heat runs so high that near the bottom they may melt into a sea, an ocean of liquid diamond, with solid diamond icebergs drifting across its surface. A buried treasure the size of an ocean on a world we could never reach. So the diamond making doesn't end with our neighbors. Billions of years from now, it will come for our own star. Our sun will one day end the same way Lucy did. After it swells and fades, its core will cool and crystallize, and the star that gave us life will leave behind a slowly forming jewel, drifting in the dark. But here's the twist that changes everything. For all their violence and rarity, diamonds may be the single most common gem in the entire universe. Look closely at almost any ancient meteorite that falls to Earth, and you'll find it, diamond. Not in veins or nuggets, but as dust. Nanodiamonds, each one a few billionths of a meter across, so small that 1 trillion of them could rest on the head of a pin. In the oldest, most primitive meteorites we have, these tiny diamonds are the most abundant stardust of all, making up a few percent of every scrap of carbon inside. And they didn't form here. They are older than the sun. They condensed in the winds of dying stars, ages before our solar system existed, and drifted for billions of years through the cold of interstellar space before falling into the cloud that became our world. Every one of those meteorites is, in part, a delivery of ancient starlight turned to stone. The space between the stars isn't empty, it's dusted with diamond. And then there's the strangest diamond of all. In 2022, scientists slicing open a rare kind of meteorite found Lonsdaleite, a hexagonal form of diamond that shouldn't really exist. It was forged around 4.5 billion years ago, when a dwarf planet was shattered by a colossal asteroid, and the shockwave rearranged its carbon into a crystal that may be even harder than ordinary diamond. A gem born in the instant a world was destroyed, harder than anything the Earth itself can make. So step back and take in the whole picture. Diamonds reign inside Neptune. Diamonds crystallize in the hearts of dead stars. Diamonds drift as dust between the stars and are hammered into being when whole worlds collide. The universe, it turns out, is not stingy with diamond at all. It makes it constantly, everywhere, on a scale that would crash every market on Earth 1 million times over. Out here, a diamond is as common as sand. We prize them because we were once told they were rare, but the cosmos is quietly drowning in them, which is the last quiet joke of the whole story. Diamonds really are forever, but out here they aren't symbols of love. They're made by pressure, by violence, by the deaths of stars, scattered across a galaxy that has no use for them and no one to give them to. And after all of it, after the lava planet, the crushed star, the diamond suns, the rain next door and the diamond dust between the stars, the most valuable world we have ever found isn't made of diamond at all. It's small, it's blue, it has water you can drink and air you can breathe. Out of every treasure in the galaxy, the rarest one is home.